Okay, guys, so here are the notes for the medians of a triangle. This is on page 7 in your packet. The start of it's on page 7 and 8. And it is Thursday, the 6th. So yesterday we talked about partitioning line segments, and that does come into play with some of this. But just going back to what a median of a triangle actually is, we saw medians of a triangle a long time ago, but they are coming back now that we know how to partition the medians. So looking at exercise 1, it says in the image below, the midpoints of the sides of triangle ABC have been marked. First thing we're going to do is draw all 3 medians of the triangle. So as a reminder, up top it's telling us that a median is a segment drawn from the vertex of a triangle to the midpoint of the opposite side. So F, D, and E are already the midpoints of the 3 sides. We just have to connect the 3 together. So you guys should all have rulers. They are set out for you. If you didn't get one, you should grab one. If I'm going to start at A, that's going to connect to E. Okay, so AE is one of the medians. If I'm looking at C, that's going to connect to D, and B is going to connect to F. Okay, so that's just drawing in the medians. It has to connect from the vertex to the side that's opposite of it, and on that side, it's going to connect to the midpoint. Okay, so for part B, it's asking us, what do we notice? What we're going to notice is that all 3 medians intersect at one singular point. That's known as a point of concurrency. So part C is asking us to just label that as P. And what do we notice? We're going to write there that all 3 medians intersect at one point, which is the point of concurrency. Okay, so that's what we notice. So they will all 3 intersect at one singular point, known as the point of concurrency. So again, the medians of a triangle are, that definition is given to you below. It says the 3 medians of a triangle intersect at a common point, known as the point of concurrency. This point is called the centroid of the triangle, and it partitions each median into a ratio of 2 to 1. So here comes the ratios again. We talked about all these yesterday when we were partitioning a segment. So when you have that point P on each of the medians up here, that's pretty much saying that out of the whole entire length, let's take, I'm going to draw it up over here, for example. So if I take CD, let me sketch that out. Here's C to D. P looks like it's a little closer to D, so I'm going to sketch it right here. That's saying that out of the total parts, right, if we have a ratio of 2 to 1, that means there's 3 parts total. Okay, so our ratio is 2 to 1. So that means there's 3 parts. Okay, CP makes up 2 parts of the 3, and PD makes up 1 part of the 3. Okay, so if we're putting them in fractions, CP is 2/3 the length of the whole entire median, and P to D is 1/3 of the length of the whole entire median. So that's going to come into play for sure. Keep that in mind. Now, looking at exercise 2, right above it, it says the 2 to 1 ratio is a result of similar triangles, as we will prove this in this exercise. So exercise 2 says in triangle ABC, the midpoints of AB and AC are D and E respectively. Okay, so I'm actually going to mark just that they are midpoints on the diagram. Okay. And medians, BE and CD, intersect at centroid P. The third median is not drawn. Points D and E are connected with segment DE. A is asking us, what do we know about points D and E? And what does this allow us to say about DE and BC? Sorry, that printed funky. What relationship do they have? So D and E, we know that they are midpoints. that we were given up above in the actual question. So they are midpoints. Notice that D and E were connected with a segment known as DE now. This we've seen a little while ago. We actually saw this back in the quadrilateral units as well, where when you connect two midpoints together in a triangle with a segment, that segment length is going to be half the length of and parallel to the third side of the triangle that it's not touching. So here, because we know that D and E are midpoints, this allows us to say that DE is parallel to BC. So I'm going to mark that. And we also know that DE is going to be half the measure of BC. Okay? Or if you want to think about it backwards, BC is equal to 2 times the length of DE. So if you know what DE is, you can just double that and get the length of BC. If you know what BC is, you can take that and divide it by 2 to get the length of DE. Okay? So what relationship do they have? We already stated that. All right, so all the information that we need to say here has been said. Now looking at part B, it says, given argument for why triangle DEP, so let's highlight this a little. DEP must be similar to CBP. So these two triangles, we're trying to figure out why they must be similar. Okay, I'm going to unscribble that right now. So those are the two triangles we're focusing on. Why must they be similar? We're going to do a little informal proof here. So we know that the two triangles need to be similar if they have two pairs of congruent angles here. So we have the pair of parallel lines and we have a bow tie situation here with the triangles. So with bow ties, we definitely have vertical angles around where P is, but we also have alternate interior angles here. So those are the angles that I'm going to use just because it'll just be a simpler, shorter explanation here. So I'm going to say right here for number 1 and 2, those two are alternate interior angles. So I'm going to say angle 1 is congruent to angle 2. And then I'll use the other pair. Here's 3 and 4. So angle 3 is congruent to angle 4. They are both alternate interior angle pairs and they are congruent. So alternate interior angles congruent. Okay, we were given from what we wrote up in part A that DE is parallel to BC. So that's why we're able to say it. The second thing, now that we have the two pairs of congruent angles, now we're just going to say that the two triangles are similar. So DEP is similar to triangle CBP. Okay. And that's it. That's all we needed here. Okay. So far, nothing crazy. Again, you could have used the vertical angles around point P if you wanted to, but you didn't have to use all 3. It was just 2. I just chose to use the alternate interior angles. So if you did use the vertical angles, you would just pick one of the pairs of the alternate interior angles, and then you would say that the triangles are similar, again, by angle. Okay. Now let's take a look on exercise 3. So now we're going to actually put some measurements here to these medians and actually pull in the ratio part of it, the 2 to 1. So exercise 3 says, in the following diagram, medians NR and OQ have been drawn and intersect at point C. If OC is equal to 18, then find the lengths of CQ and OQ. So what I like to do is I honestly like to kind of re-sketch out the median that I'm focusing on off to the side so that I'm not looking at a million things in the picture, especially if you're going to be marking up measurements. These two questions work off of the same picture, so it'll be a lot. So if you want to draw it off to the side, I'm going to do that right now. So we're focusing on OCQ right now. Okay, and then it looks like C's a little closer to Q. So here's OCQ. Again, we know that the ratio, the matchable ratio, is 2 to 1. That means there's 3 parts. And the first part is 2 out of the 3 parts, and the second piece of this is 1 out of the 3 parts. So they're telling us that OC is 18. This has a length of 18. We have to figure out the length of CQ and OQ, which is the whole entire median. Whole median. Okay. So what I could do here is, because I know the length of OC, and that's 2 out of the 3 parts, CQ is 1 out of the 3 parts. So O to C is going to be double the length of CQ. So what I'm going to do is I'm actually going to take the 18 and I'm going to just divide that by 2 to get what CQ is equal to. So for CQ, that's going to be equal to 1/2 the measure of OC, which if we set that up, we're going to do 1/2 of 18, which is just going to give us 9. So CQ, I'm going to get rid of this, is going to be 9. And that allows us now to be able to figure out what the whole entire length of OQ is. OQ is both OC plus CQ put together. So if I have 18 plus the 9, OQ is going to equal 27. Okay? So that's how we'll find CQ and OQ. So that's if you're given one part of the median and you're asked to figure out what the other piece and what the whole thing is. Part B is asking us to figure out what the pieces are equal to if we know what the whole entire length is originally to start off with. So NR is the other. Let's see. Okay. So NR, just to have a different picture here. NR. C is a little closer to R. Okay, so again, this is the 2 parts, which is the same thing as 2/3 of the length. And then this is 1 part, which is the same as saying this is 1/3 of the whole entire length. Okay, so NR, we're told that the whole entire thing is 36. Okay, and then we need to figure out what the lengths of NC and CR are. So what we're going to do is we're going to just take the fractions of the parts that we have for each piece of it, and we're going to multiply that with the full length. We actually had a homework question on this yesterday. I believe it was question 6 that you guys had to do this on. So to find NC, what I'm going to do is I'm going to take my fraction, which is the 2/3, and multiply that by the 36. So let's do that. If I have the 2/3 times 36, I get 24. And we can use the trick that we had up above, but just so that we're really driving home the point of using the fraction of the parts multiplied by the whole length of the segment, I'm going to do that again here for CR. CR is 1/3 of the whole entire length of NR. So that will give us 12. Okay, so 24 and 12 are what we're looking for here. So that's how you can find the lengths of the pieces of the medians or even the whole length like we saw in part A. Okay. We're going to scooch on down to exercise 4. We don't even have a picture here. So when in doubt, draw it out. We know that we have triangle ABC. So I'm going to sketch out a triangle. Here's A, B, hold on. A, B, and C. We're looking at this. We have the median from A to side BC starts at A is -410 and ends at D 11 -8. So that means that the median is connecting A to D together. So this point here is D, and that's the midpoint of side CB. They're also telling us that there's a point P that's the centroid of ABC. So I'm going to put P right here. Determine the coordinates of point P and show how you arrived at your answer. So this is exactly what we did yesterday. We learned partitioning a line segment yesterday, so that's what we're doing. The ratio that we need is the 2-to-1. We have the coordinates of the endpoints of this line segment. So we're going to start by going over finding the change in the x value and the change in the y value. So just marking some things up. We're going to have A is our x1, y1, and D is our x2, y2. Okay. So now finding the change in x, that's your x2 minus x1. That's going to be 11 minus a negative 4, which is keep, change. So that's actually going to give you 15. If you don't believe me, you can check it in your calculator. And then we also have y2 minus y1, which is going to give us negative 8 minus 10, which will be negative 18. So that's the change in x, the change in y. Our ratio here is the 2-to-1, so 2 is m and 1 is n. So if I'm setting up my ratio to find the fraction that I need to include in my formula, I'm going to have it as 2 over the 2 plus 1, which gives me the 2/3. So the 2/3 is my fraction, and I need to use A in my formula, which is negative 4, 10, because that's your x1, y1. Hold on. Oh my gosh. There you go. Let me get rid of this. That's our x1, y1. Now I'm going to find what the coordinates of xp and yp are. So we've got xp. That's the x value of the first coordinate, so negative 4, plus the fraction that we have, which is 2/3, times the change in x, which is 15. Okay, let's plug that into our calculators. So we've got negative 4 plus the 2/3 times 15. And we've got 6 as our answer. So equals 6. And then now following the same format for y, I'm going to take the y value of my first coordinate, which is 10. I'm going to add that again to my fraction, and then multiply that by the change in y, which was negative 18. So let's again plug that into our calculator. We've got, that was 10 plus the 2/3 times negative 18. Boom. We got negative 2. Okay, so that's our x and y value of the coordinate. So if I'm asked to figure out what the coordinate for P is, I'm going to say it's 6, negative 2. This is our xp and our yp. Okay. There we go. We found the coordinates of point P that partitioned the segment AD into a ratio of 2-to-1 because it's a median. Okay. So that is all what we did yesterday. The only thing that's new with what we did yesterday is the fact that we have the 2-to-1 ratio there because we're working with medians. So this 2-to-1 ratio, you need to know that, because in this question, as you can see, they don't even give you that ratio. You need to know it. Okay, so just keep that in mind. All right, this is the last exercise, and then you guys can work on the homework questions. With exercise 5, it says, in triangle ABC shown below, points D and E are the midpoints of sides BC and AC. So just from that, I'm going to mark E and D as a midpoint. It just helps my train of thought. We know that medians AD and BE have been drawn and intersect at point F. Which of the following is not a true statement? So just go through your answer choices here and see what is not true. So looking at number 1, ED is parallel to AB. ED is indeed parallel to AB. Okay, that is one of the properties of a segment connecting two midpoints together. So this is true. We're crossing out 1. We want what's false. Number 2 says EFD So this triangle here is similar to this triangle here. That is also true. Okay, we figured that out back in exercise 2 when we showed that little informal proof about the two triangles being similar. So that is true from exercise 2, not trying to rhyme here. Okay. If I'm looking at 3, it says EF is equal to half the length of EB. So EF is this little piece here. Is that half of EB, which is the whole entire median? No. That's actually 1/3 the length of the whole entire median. Okay. So this is false here. This is actually going to be our answer. EF would actually be 1/3 the length of EB. Okay. And then the fourth one, just to kind of go through it with you guys, it says the median drawn from point C to side AB would pass through point F. Yes, it would, because that is F is the point of concurrency. All three medians, like we saw in exercise 1, connect all at one point, known as a centroid. Okay, so this is also true. Okay, we learned this in exercise number 1. Okay, so that's the notes for today. The homework questions that apply to these notes. So we had questions 1 through 7 done. So I believe it's 8, 9, 10. Yep. So questions 8, 9, and 10 are what we have for homework today. Okay. So that's what these notes today apply to. Go ahead and try them out. I'll have my notes up on the Google Classroom page. Actually, let's go to that right now. Why not? So I'll go to period 3. So on all of your classrooms, whether or not you're period 3, 6, or 9, if you look at the homework 7, the unit 7 homework assignment number 3, again, my due date is there for you guys. Just picking up this PDF here. Okay, so you'll see my notes from all the previous questions on here, but just kind of picking up. Whoa, I have no idea what's going on right now. Okay, so here's 8, 9, and 10. These are the 3 that do apply to what we did today. Okay, so this is for 3, 6, 3, 6, 3, 6. Okay, so if I'm looking at number 1, we have in the diagram shown medians CG and DF intersect at point H. If CH is 10, then which of the following is the length of C to G? So you're looking for the whole entire thing. I definitely would recommend sketching out the whole entire median separately. So here's C, H, G. C to H is 10. They want to know what the whole length is. Okay, so I'm going to say find HG. And then you'll add CH plus HG together to get CG. Okay. For number 9, and actually, sorry, backtracking to question 8, if we are looking at that one, the exercise that we did in the notes that applies to this question is exercise 3A. So I'm going to say similar to exercise number 3A. And then for 9, it says in triangle MNP, medians NQ and PR intersect at point S. And then they're giving us a bunch of measurements. And notice that we don't have anything drawn out for us. So let's draw that out. We know we have triangle MNP. Doesn't matter what kind of triangle you draw. Here's M, N, P. NQ is the median. So that means from here to the midpoint, Q is your midpoint here. And PR, so P is connecting to a midpoint R over here. So this is also a midpoint. Okay, and they intersect at point S. So here's S. If P to S is 8 and Q to S is 3, then which of the following is the value of NQ plus PR? So NQ plus PR, that's adding the whole, so add whole lengths of both. Medians. So you guys are going to have to figure out what RS is and NS. So I would probably say separate out the medians and use exercise number 3 to help you. Okay, so very similar to exercise 3 as well. And then for 10, says on the grid shown, triangle ABC has been plotted with vertices at A is -1, 8, B is 7, 4, and C is -3, -3. If the median from C to AB was drawn, at what point on AB would it terminate? Give the coordinates and plot the point, label it as point D. So if the median starts from C and it's connecting to the side AB, right, point D is going to be the midpoint of side AB. So I'm going to say for this question, find the midpoint of AB, right? We have the coordinates and you have the coordinate plane. If you want to use the formula, that is where you add the X values together and divide by 2 and then add the Y values together and then divide by 2. Okay, that'll get you point D. And then they want you to draw in the median. So you'll also just connect C to point D. And then C is asking us to determine the coordinates of the centroid of this triangle and justify how you found your answer. Plot the centroid and label it point P. So this one, I'm going to say follow the same steps as exercise number 4. So follow same steps as exercise number 4. Okay, we did notes on that all day yesterday, so you have plenty of notes to help you out with this question. But again, tomorrow I can check on this stuff for you guys if you want me to tell you if anything's right or wrong. Okay, so 8, 9, and 10 are what you have for homework, and this can be found on Google Classroom no matter what class period you are, underneath Unit 7, where you see Unit 7 homework assignment number 3. Okay, and that's it.